Hello and welcome. Today we're going to be discussing dividing a polynomial by a monomial. Previously, we've talked about taking out the greatest common factor of a binomial. What we're going to be doing today is a very similar process. First, I'd like to recall factoring a binomial. What we've talked about in order to factor binomials, as far as we've discussed, is all we are going to do is simply look for the greatest common factor of the two terms. So looking at these two terms, the greatest common factor I see is a 4. So I factor out a 4. My 12x becomes a 3x, and my positive 8 becomes a positive 2. You know you have done it successfully when these two terms inside your parentheses no longer have anything in common. You may check your answer by distributing the 4 back in. What you should end up with is the original binomial that you started with. So we'll check this answer. 4 times 3x is 12x, and 4 times positive 2 is positive 8. Since that does match our original binomial, we have factored correctly, and 4 times 3x plus 2 is the factored form of your binomial. Here I'm going to factor out my greatest common factor of positive 8. So 8 is on the outside of parentheses. Taking an 8 out of 24x, I end up with 3x. And factoring 8 out of negative 16y, I have minus 2y. Again, we know that we took out the greatest common factor correctly when there is nothing left in common between the two terms in parentheses. If you'd like to check your answer, you may distribute the 8 back in and it should match your original binomial. So 8 times 3x is 24x, and 8 times negative 2y is negative 16y. Since that does match my original binomial, we did factor correctly. And your factored form is 8 times 3x minus 2y. Go ahead and take a moment to pause the video and practice the next two on your own. You should have 5 times 3x minus 5 for the first, and 2 times 13x minus 10y for the second. What we are going to go into now is dividing a polynomial by a monomial. What we are going to do in order to complete these division problems is simply break up each of these large fractions below into a bunch of separate fractions. You must take caution when you are doing this. Make sure that you remember you may not reduce over addition. One of the most common mistakes in these type of problems is that students will reduce, for example, down here. They'll look at the problem and say, hey, 12 and 2 can reduce to a 6 and a 1. And so they say, on the top, I have 18x plus 6, and on the bottom, I have a 1. So my answer is just 18x plus 6. Now the problem is, way back here at the beginning, there was a plus sign in between your two terms. So what I did is actually not allowed. I may not reduce when there is a plus sign between two terms. I may only reduce over multiplication. So what I'm going to do first is break this up into two separate fractions. The first is 18x over 2, and the second, since there's a plus sign in the middle, I add on a 12 over 2. You can imagine adding these two fractions together. If you added them together, since the denominators are the same, you would end up with exactly what we started with. So all we're doing is we're breaking it up. Now in the first fraction, notice there is no addition or subtraction here. So what I can do is reduce the 18 to a 9 and the 2 to a 1. So I end up with 9x. And on the right, 12 reduces to a 6, and the 2 reduces to a 1, so I end up with a plus 6. And this is the final reduced form of your original division problem. To the right, I'm going to repeat this same process. First, I rewrite my two separate fractions, 21x over 7 plus a positive 42 over 7. Reducing the first fraction, since there is no addition or subtraction inside the fraction, 21 becomes a 3, 7 becomes a 1. So I end up with 3x plus, from the right, 42 reduces to a 6, 7 reduces to a 1. So I end up with 3x plus 6. Lastly, on this slide, I'm going to repeat this same process, splitting up my numerator into two separate fractions. The first, 18x to the third, y to the fourth, over my denominator of negative 6, x to the second, y to the second, plus the second term in my numerator, which is 12, x to the second, y to the fifth, all over my denominator of negative 6, x to the second, y to the second. 18 and negative 6 reduce to a 3 and negative 1. So I end up with a 3 on top, negative 1 on the bottom. X to the third on top and x to the second on bottom reduce to simply x to the first, or just x in the numerator. My y's reduce. I have y to the fourth on top, y to the second on bottom. So that reduces to y to the second in my numerator. This negative can be brought to the top, leaving me with simply negative 3x y to the second. Plus my second term, I reduce my 12 and my negative 6 to a 2 and a negative 1. So I have 2 and negative 1 on the bottom. X to the second on top and bottom reduce completely, since they're exactly the same. And my y's reduce to y to the third in my numerator. Since it's y to the fifth on top and y to the second on bottom, I'm left with y to the third in my numerator. Now, just as we did before, I'm going to bring this negative up to the top and end up with a minus 2y to the third. And that is the most reduced form of your original fraction. We are going to repeat a very similar process here on this slide. The only difference is that we now have 3 terms in our numerator instead of just 2. I'll go about it in the exact same way. I am now going to write 3 separate fractions. The first, 36x to the fourth, y to the third, over my denominator of 9x to the third, y squared. I have a minus, so minus, my next term is 27x to the fifth, y to the fourth, over my denominator of 9x to the third, y to the second. I have another subtraction, so minus 45x to the third, y to the fifth, over 9x to the third, y to the second power. Reducing my first fraction, 36 and 9 reduce to a 4 and a 1. So I end up with 4 on the top, 1 on the bottom. My x's reduce, x to the fourth on top and x to the third on bottom, reduce to just x to the first in my numerator, or just x. For my y's, I have 3 on top, 2 on the bottom, so that leaves me with just 1 on the top, and those cancel. Minus, I reduce my 27 and 9 to 3 and 1, so I have a 3 on the top, 1 on the bottom. I have 5 x's on top, 3 on the bottom, so that leaves me with x to the second in the numerator. For my y's, I have y to the fourth on top, y to the second on bottom, so that leaves me with y to the second on the top. Minus 45 and 9 reduced to 5 and 1. So I've got 5 in my numerator, 1 in the denominator. X to the third and x to the third cancel out completely. And y to the fifth and y to the second reduce to y to the third on the top. Since all the denominators are 1, I may simply write this without the denominators. 4xy minus 3x squared y squared minus 5y to the third power. And that is the most reduced form of your original fraction. Go ahead and take a moment to pause the video and try the next one on your own. After writing your 3 individual fractions and reducing, you should have obtained 2x to the second minus 5x plus 1. We're going to now go into factoring binomials by again identifying the GCF as we did before. However, here we're going to have more than just a number for your greatest common factor. We are going to have a number and a variable for your greatest common factor. Also, what we need to note is that the leading coefficient, your leading coefficient, just to remind you, is the very first coefficient of your polynomial. So for example, in something like 8x to the third minus 5x, the leading coefficient is the 8. It's the coefficient of the very first term. This number must always be positive. If this number is negative, then we have to make sure we factor out a greatest common factor that is negative in order to change that leading coefficient to a positive. So right away, looking at this binomial, I see that my leading coefficient is negative. So I'm going to go ahead and make sure that my greatest common factor is negative so that I take that negative out. Then I look for whatever else these two have in common. I see that they both have k's. The most that I can take out, since the first term has 2 and the second only has 1, I can only take out one of those k's. So my greatest common factor is negative k. What I have left when I factor from this first term is a positive 3k, and when I factor from my second term, that positive changes to a negative 8. And I have taken out the k, so it's simply negative 8. Again, you may check your answer if you'd like by distributing that greatest common factor back in. Below to the left, my greatest common factor is going to be negative, so that my leading coefficient ends up being positive. And these two terms can both be divided by 7. Since the first has n squared and the second only has n, I may only take out a single n. So on the outside of parentheses, I have negative 7n. 63 divided by negative 7 is a positive 9. And since I took out one of those two n's, I have positive 9n. I factored out a negative 7 from positive 70, so that gives me negative 10. And I took out the n, so all I have is negative 10. Go ahead and try the next 3 on your own after pausing the video. For the first, you should have a greatest common factor of positive 4 n to the 4th. When you factor that out, you should have n minus 1 left in parentheses. For the second, your greatest common factor should be negative 2 m to the second. When you factor it out, you should have 2m plus 1 left in parentheses. For the last, you should have negative 3x as your greatest common factor. And when you factor it out, you should have 8x squared plus 7 left in parentheses. Go ahead and take a moment to try these next 4 on your own. The greatest common factor of the first should have been 4x to the 5th y to the 4th. Remember to find that. You first look at your coefficients and find the greatest common factor of these numbers. It is a 4. From there we look at the x's. We have 5 and 7, so the most we can take out is 5. And then looking at the y's, I have 8 and 4, so the most I can take out is 4, giving us our greatest common factor. Factoring that out, you should have 8y to the 4th minus 5x to the second left in parentheses. For the second, your greatest common factor should have been 10w to the 7th, z to the 3rd. Factoring that out, you should have had 5w squared plus 2 in parentheses. Third, down to the left, remember that you must have a positive leading coefficient. Since this is negative, I made sure and I took out a negative in my greatest common factor. So I have negative 4h to the 4th j, leaving me with 4j plus 7h in parentheses. And to the right, again in my greatest common factor, I took out a negative to make the leading coefficient positive. So taking out negative 3x squared y to the 6th left me with 5x squared y plus 3 in parentheses. Thank you very much for watching. I hope you enjoy the rest of your day.